So welcome to a new series where I'm going to try and figure out how to manufacture circuit boards using a low-cost CNC. I think I'm going to set the bar pretty high. I'm going to try and figure out if I can actually make high-quality double-sided circuit boards with surface mount components. So high-density, high-quality boards. Now, I'm not at all new to manufacturing circuit boards. In fact, when I was pretty young, the first thing I did when I was actually trying to make my own electrical devices, instead of actually trying to wire it, I actually went out and sat on my grandmother's living room floor, had her nice china with some ferric chloride acid in there, drew on with a pen onto a bit of copper board a circuit, and I think I was using these pads here. These are scratch-on pads. You actually scratch them on, and that gives you the pad. I etched the board and put it together, and it didn't work. I mean, that's just the way it goes. I mean, it's the first thing I ever made. But, you know, I think it showed a keen interest in making circuit boards, even from a fairly young age. So after that, I'd actually leveled up and actually had a little bit of success. This is probably about the third thing I ever etched. And it's using some recycled 7-segment displays and some recycled cable and whatever. But it's actually surface mount, which is pretty cool. I think it says 91, so it's pretty old. You can see the traces are not specifically good, and you can see that they're all hand-drawn. So this is a simple counter and display. This is three display drivers for driving these displays, and 2 sets of dual BCD counters. Now there's only 3 displays, so only 3 of the BCD counters are actually used. And the back end of this is actually this lovely work of art here, which is actually a staircase generator. So it uses these voltage dividers to create a staircase, and then measures the point at which the voltage changed so that these counters stop counting. And yeah, it's a bit of a mess, but surprisingly it actually still works. So fairly amazing if you ask me. Look at some of this. Oh my god, it's just like a bird's nest. But it works, and what I actually use this practically. This is actually for measuring the voltage of my variable power supply. So this is a voltage measuring and display unit. And I didn't actually know probably what I was making then, but this is actually the fundamentals of an analog to digital converter, but in a very disgusting form. Anyway, this is sort of where I was. Now, at this time I was working in an electrical appliance store, delivering refrigerators and TVs and selling them as well. So that's sort of my background in electronics. But luckily after that I managed to get a proper job. Well, that was a proper job too. I mean, I shouldn't say that, but I got a better job. And thankfully it had the ability for me to actually study electronics a little bit better on the job, so apprenticeship type of things. And they also had some facilities, some workshops and things like that. So in the off time I would go and make my own stuff. And here's something that I made, for example. This is a simple board that I manufactured. I actually draw this in AutoCAD because I didn't have any good sort of dedicated PCB designing software. So I would actually draw these pads and everything in AutoCAD and draw all the lines. And this was actually being made using a photo etch type solution. So you would use this type of board. This is actually a Farnell part photoresist copper clad board. And this black sheet here, you would go into the dark room, you'd take this sheet off, you'd put your positive resist on there, which is a transparency, and you would expose it to UV light for a certain amount of time, and then you put it into a chemical wash to wash off all of the unwanted resist surface, and then you put it into your ferric chloride etch or whatever your etchant was to remove the copper you didn't want, and that's pretty much the result. And so here's what the board looks like after it's been etched. This is the board that's just been etched. The photoresist is still there. You can see that sort of that purple color. And this is also drawn in AutoCAD, by the way. This is actually a part of a system that I'd made a long time ago, as is this board here. So this is the power supply board, and this was a static memory board with a battery backup and some counters on there. And this was an analog to digital, from professional audio to digital to analog audio converter, basically. And this was a jingle audio player which I built for a radio station. So just before the news runs on a radio station, you hear the jingle, and this is what I made. So this is something that I made in my own time and then sold it back to a radio station. So it's quite interesting what opportunities are out there for those young people who want to give it a go in electronics. And I think those opportunities still are there today. And a lot of people want to give young people opportunities. So definitely endeavour to try and do things that people tell you are impossible. That's for sure. So yeah, this is only just one of the projects I had. Look, I've done dozens of projects that I've built my own PCBs. Some of them are really big. Now, look, if you have an interest in that, I'm more than happy to share those in the channel as well. And we can go through and we can look at some of the signals on some of the boards that I've made over time. I think they're pretty interesting. Maybe I'll do it. Maybe I won't. I'm not really sure. Now, look, I've also have been involved in mass producing boards as well in different circumstances. And, you know, if the quantity is probably more than 10, then I definitely wouldn't be manufacturing these types of PCBs by hand. I would definitely be outsourcing it. Even 25 or so years ago, it was still pretty cheap to do that. There were companies that would do that in Australia, where I'm originally from. So, you know, here's a board that is a circuit that I've designed myself and that I've outsourced. And I think had over 100 of these boards manufactured. And yeah, it makes a lot of sense. So you really only want to be making boards when you're only like this yourself, if you're doing quantities about 4 or 5 or 6 or something like that. I think I made it up to about 8 of these boards. But anything over that would be pretty, it doesn't make any sense basically, cost-wise or otherwise. So there are upsides and downsides with getting PCBs made as well. And there's some cheap places you can get them made in China. So you just think, well, just get it made in China, whatever, it's easy. But it's a little bit more complicated like that, because the reality is that you need to iterate. When you manufacture a PCB, you're going to get it wrong. And every time you iterate, there's a cost and there's a time delay. So typically what will happen is you will just not iterate after your first board. As with this board, for example, I'm pretty sure we didn't iterate. And there were manufacturing errors, because we'd actually pretty much given the circuit and basic layout to this manufacturer, and they pretty much did the rest. But even so, they'd managed to miss a few traces. For example, this trace was missing, this trace is missing, and there's a couple of other, there's like 5 or 6 traces missing. It's just silly mistakes. And if you were iterating, if you were actually being able to do 2 or 3 versions of the board before you went to manufacturer, that would be fine. And if you're a big company, you can do that. But if you're a small company, you can't. And even some big companies still don't iterate. They probably get to about 2 generations and still discover an issue and then do these reworks. It's just the way it is. So being able to manufacture your own PCB has a role to play in various places. If you're doing a one-off, specifically you want to have a PCB, you don't want to have that garbage sort of hand-wired board. For example, my mini lathe was a one-off. I would have preferred to have made a PCB for that, but I didn't have the systems on hand to do that. So I wired it by hand. I think that's fine to wire it by hand, and you should wire it by hand if that makes sense to you as well. But I would have preferred to make a PCB. And I wouldn't have made a PCB by sending it to China, because I would never be happy, right? I'd send it to China, I'd get it back in a month, it'd be wrong, and I'd send it again, and it would just be costly and take a lot of time. So in that case, I just hand wire it. But if I could manufacture the PCB by myself, I would. And if it would take me 2 or 3 iterations to get it right, I'd do 2 or 3 iterations. And it would only take me, 3 or 4 days to get the final and completely correct product. And that's not going to happen working with those China operations. And I think the other thing is just, building your own skills as well. Being able to make a PCB, design the PC, manufacture the PC, teaches you a lot more than if you just chuck it to somebody else and they do it. And at the end of the day, we need more skills in the population. We can't just outsource everything to the rest of the world. We need to understand how some of this stuff works. Anyway, so I think that's my rant and my explanation. As I said, if you want to look at some of my historic projects and you want me to have a look at them, leave it in the comments and I'll definitely give it consideration. I mean, you don't know what they are, so I don't know what that even means, but whatever. Here's a board. Here's that raw board from here I made. Now, look, there are things that I never liked about these boards. One thing is I couldn't do double-sided, and I want to do double-sided in this project. So one of the objectives of my project is to be able to do accurate double-sided boards. So because I couldn't do double-sided, I would actually just run these wires. Look at that, some of them on the angle even, that's pretty creative, right? So double-sided, and there's no mask on this. I want to be able to try to figure out how to get a solder mask, the writing is so you know what chip is what. And I could never really do it in those times. What else do I not like? I don't like the finish. It doesn't look professional. It doesn't have the solder mask on it, for example, which means that you get all of this solder overrun and etc. running everywhere. So I want to have the resin solder mask on it, and I want to have I want to get rid of all of the manufacturing problems that I used to have. And for example, if you look here, this is a completed board, and it's pretty good, and the tracks are pretty fine. In fact, I'm really surprised at how fine I managed to get some of these tracks. Not fine enough to run up between the legs of those surface mount chips, but no, nothing there. But if you look at this, this is a failed side of the board, and you can see here there was some problem either with the transparency or the UV exposure process or something that just meant that I couldn't etch it properly. So this is a failed board. This is a failure in the yield. And that was one of the things that you would have. And you can even see that even on the transparency when I printed it, there were some errors in the transparencies, and I got out the black pen here. You can see I'm black penning there to try and fix the transparency. So it was a messy process, and it wasn't that accurate. And I was never all that really happy with it. You can even see a little bit of rework here where I've actually ground away tracks that didn't quite work right. So recently CNC manufacturing of the PCBs are all the buzz, and it's really caught my eye, and I want to try it out, and I don't want to spend a lot of money on it because I'm a tight ass, or whatever you want to think about me, but it is what it is. So I spent a bit of time looking across YouTube and looking at a few different videos about CNCs, figure out which one I wanted to use, and I've chosen what is called a CNC3018. It seems a very generic sort of device. So that's what we're going to be using, and you're definitely going to be seeing it in all of these episodes. So I hope you join along, and I hope you learn something, as I will definitely be learning something in this process for sure. So let's get straight into it. Let's stop waffling on. I could waffle on for hours about nothing at all, but let's get into it. So here we have something new on the channel today. It's a 3018 CNC. Now these have been around for a while. Apparently, as far as I can tell, they originally look like they come from somebody's 3D printer project, self-homemade CNC. In fact, all of these parts here, as far as I can tell, originally even sold in distribution as 3D printed parts. So that's quite interesting. Now they look like they're all injection molded. Now before purchasing this, I actually started to do some research in actually building my own CNC from scratch. I didn't really think buying a cheap CNC and then having to rebuild it might have been the best way to go. And after a little bit of research, I actually found some guy on the internet who has put a video up on YouTube, and he's built a CNC for $100, or supposedly for $100. But if you look at his video, he's basically taking about $80 of parts from a drawer he had and spending $100 on parts. Now, this unit here, I got a good price on Amazon for about $150 fully running. So, you know, you could spend $150, or if you are lucky enough to have a pile of parts and you could put something together, that might work too. But for me, I didn't have any experience with this CNC, so trying to do that from scratch seemed to not make much sense. So just go straight in and get something that's working, and then customize from there on. Now apparently there are a couple of different versions of this CNC. It's sort of like an Ender, right? People have made all different sorts of versions of those and stolen it or whatever. It seems to be quite open source. And what you'll find is that some have parts here which are aluminium. Some of them, I don't know, are fully aluminium, have bigger motors on them and all sorts of stuff. The controllers are different. The stepper motors are different. You know, there's a whole range of different things that you can get. But as these have been around for a while now, they've been quite standardized. So that means there's a lot of support in the market for them, even though you have to be a bit careful because different parts have different sizes and things don't fit on this and things don't fit on that. But generally said, they do have a good support in the market. There are other different types of weird CNCs out there as well, but you know, for me, it's like the mini lathe. I'd rather go mainstream, the thing that has the most amount of community support and spare parts and things like that in the market. So the 3018, just so you understand what that means, the 3018 is this here. We have 300 by 180, so that's where the 3018 comes. It's from the size of the cutting bed, and this here has a ER11, a very small collet, so you can actually change that. And the motor that comes with it is some very cheap brushless motor, but even with that said, it does have an internalized fan, so it's intended to keep running. So they really have spent the time to develop this to quite a good degree. And the controller as well on the back here, if I spin it around, we have this nice little board on the back here. Hopefully I don't get myself on the shot. And it's inside here is a Atmega 328P. It's an Arduino Uno basically. So this board originally was an Arduino Uno, and what they've done is effectively gotten rid of the shield and compacted into this single board. But as far as anyone's concerned, this is just Arduino. Whoa. Let's hold on there for a minute. I think that explanation is a bit too hard and fast. So let's try and explain a little bit better. So here I have what is effectively the same controller, but in its original form. So this board here is a breakout board, but effectively with some capacitors on it. You can see otherwise there's no componentry on here, and it's just a Arduino Uno shield. So this is the Atmega 328P. The shield goes on here, and there's these slots in here. There's up to 4 slots, X, Y, Z, and I guess A is something extra. So these are your little stepper motor drivers, and there's a couple of different versions of these stepper motor drivers you can get, some silent, some not, some better than others or whatever. But anyway, you plug that in there, put your heatsink on there if you want to do that, and that's it basically. All you need to do is use Arduino to load the GRBL 1.1 software onto it, and you have all of the parts are needed for a controller. And as I said, this is exactly pretty much the same as that controller board you're looking at in this CNC that I've got. The only thing that's different about this arrangement is that there is no motor speed controller, so that would have to be external of this board. But you know, it has end stops and all of the tricky little things and bits and pieces, and pretty much the same. So the way this works is that this has your typical Arduino Uno serial over USB based controller. You plug it into your computer and you're talking text between here and here. So the way it actually works is that this obviously doesn't have that much memory or whatever. It probably can cache a little bit of the data, but you have a piece of software, which is, I think it's called Candle, and it's a GRBL control software, and it's just feeding the G code to this machine, and this machine, or this board here, is then sending out the commands to the stepper motors as need be. So it's really, really not complicated. There's nothing tricky in here. If you do a quick search on the internet for GitHub and GRBL, you will quickly find that the open source software is there for you to access, and you can make your own CNC. It's really as easy as that, and it's pretty cool, I think, too. So I believe the latest version, if I look on the site there, is GRBL 1.1H. I'm not really sure about all the differences, but I just call it 1.1 for general, and it seems pretty stable and seems to work really well. And that's how you make your own CNC. And the good thing about this board, it has a lot of expansibility. It has all of the end-stop sensors and a remote control panel input, and you can support a laser, all sorts of stuff. So amazing expandability. And on the stepper motor drivers, which are all built into the board here as well, they even have a little fan on here. So this is good stuff. You know, I'm pretty happy with the way it works. Not to say that I am intending to use it as it is, but you know, it allowed me to put together. I mean, it comes as a kit form, so you have to put it all together. It doesn't take long, maybe about, depending on how fastidious you are, it might take you about half a day to a day to get it all up and running, but it's not too bad. It was pretty straightforward to put. And I have like a packet full of parts and stuff here, so they give you pretty much everything to get you going. And I'm not going to bore you with watching the cut, but I did a few little test cuts here, and you can see this is just some simple cuts that they had on an SD memory card they give you with it, and you can see it works quite well. It's fairly accurate and in depth and in position, so it's a pretty impressive device overall for $150. So let me go back to the typical hand shot that I do, and I'll go through and I'll show you the bits and pieces that came with this CNC out of the box, and I'll also show you a few things that I've purchased before I actually go ahead and do the upgrades on this
Yes, that's right. I'm going to go straight into doing upgrades before I actually use it, because, you know, it is fine as it is, but I really want to have the best performance as possible as I get into it. And so I've already run it, I've done the tests, I know it works, but it's really not going to be quite good enough for what I want. I really want something a little bit more sturdy and powerful.
So let's take a look at what we got in the box. Obviously, first of all, we have a little brick power supply.
Let's have a look at that. What's that say?
24 volts output, 5 amps. It's probably good enough to drive those stepper motors. So maybe 1.5 amps per stepper motor peak, and I don't know, maybe 1 amp for that motor or so. So yeah, I mean they've judged this to be just about right. So you wouldn't want to be overpowering it too much, otherwise you're going to need a new brick. I think I'll get away with it for a little while. We'll see how it goes. And then I have this bag of goodies. Brush. A nice mini USB cable for the controller. USB memory. There is your arbitrary set of hex wrenches and a few extra bits and pieces, a spring and a coupler and a few extra screws. These are left over after I built it, so obviously they chuck a few extra bits and pieces in the box to make sure that you don't get in trouble. Spanners for the collet and probably a few other bits and pieces. 10, I think these are 0.1 millimeter 20 degree cutting bits. I even wrote it on there so I don't forget. And these work pretty good, but 0.1 millimeters pretty sharp, so if you drop it, for example, even from a short distance onto that surface plate, that aluminium surface plate, I noticed that they will get blunt pretty quickly, so you better be careful with that. In fact, I did blunt one pretty quickly. And what else have we got? Some hold down screws. Now these are pretty pathetic, but they do the job. T-slot and surface of the mounting surface, and your work here, and then you screw down here to put pressure on your work. So I'm sure most of you know all that. So it's a hold down, yeah. And the other thing that came with this one, I bought the one that has an offline controller on it, which looks like something again that's been homemade at some point that they've thrown onto this system. So just in case you know, I think it's the software that this system runs on is GRBL 1.1, and that's off the top of my head, so I could be wrong. So there are two ways of operating this mini CNC. I'm giving it a name now. One way is to use a computer with a piece of software that directly is telling the controller where to position and move it. So it's effectively decoding the G code and sending the specific coordinates down this cable, or step-by-step commands down this cable. I really don't know the specifics of it, but anyway, the key memory for driving the events on the G code exists within your computer, and you drive it over the USB through that little Arduino Uno type device. And then the other way to do it is using this offline device, and this offline device allows you to put in a card with it's a little adapter actually with a micro USB, so you can put your G code on here just like with a 3D printer. Put it in here. Different to the 3D printer, however, you need to set up the position for your zero, so you align your motor head, whatever, chuck, to the 0 point in relation to your G code, and you can then execute it. So I think, I'm not really sure what I'll end up using, to be honest with you. The good thing about the computer driven model is that you get to see a little bit more about what's going on, what's going to happen, and in that very dynamic mechanical environment, it's sort of nice to sort of have a little bit of foresight of how it's all going to work and feel comfortable with it. On the other hand, you know, having the offline is like a 3D printer. You know, we're happy with that. We put in the card and put in the file, and we let it do its thing, and we hope like hell it works okay. So Yeah, I think either way, it's probably going to be okay. I'm on the fence. We'll see how it goes. The other thing with this is that it has a mini USB connector on here as well. So I believe this acts as a USB card reader as well, which allows you to read it off here. Anyway, it's sort of nice to have. I think these cost around about $10 an option, so it's not an expensive option, and it brings, you know, a capability that you wouldn't otherwise have. So it's quite nice to have. Brush. Did I do the brush? I don't remember. All right, so that's all the stuff that comes with it. Now let me show you some of the stuff that I bought. Now, to be honest with you, I didn't actually buy this particular thing for this CNC. However, I have noticed that the stepper motors that come with the CNC are a little bit weak. So if I want to cut a little bit heavier materials, it's going to start missing steps. So I'm likely going to put in the stronger set of stepper motors. I think this stepper motor here has around about 0.42 Newton meters of holding torque, whereas the ones that are on it only have like 0.28 or something like that. So it's quite a good step up to have these stepping motors on there. So originally I bought this actually to do some CNC work with the mini lathe, which I still intend to do, but I think I'll use 3 of these here straight onto the CNC. The other thing I got is this laser, and it says it's a 40-watt laser. So apparently these are all overstated. I don't understand how they come up with this naming scheme, why they try to confuse people. So it says it's a 40-watt laser, but I think this is referring in theory to the electrical power. The optical power is like 5 watts. When we're talking about a CO2 type laser, I think when they talk about 40 watts, they're talking about optical powers. It's around about an eighth of the power of a decent CO2 laser. So it's not that powerful in theory, but actually it is pretty powerful. Apparently it'll cut through 5 millimeters of plywood, moving relatively slowly, but at a relatively usable speed. So 5 millimeters is a pretty serious cut in my book. So I think it's good enough. And the shape and size is such that you can just put it straight in that mount and away you go. So this is going to be quite nice. Now, I'm not sure what I'm going to use this for exactly yet. I have a lot of ideas. You can use it for in the process of manufacturing PCBs. You can use it for cutting leather, for cutting wood, and etc. etc. So there are lots of different things you'll be able to do with this. So I'm pretty interested in trying to see how this will be used. I also purchased a whole lot of extra bits, which will be interesting. This is 30 degree 0.2 mil for the PCB. I've read that the 20 degree 0.1 mil is just too fragile for PCB, and this is just a whole bunch of PCB drills or milling bits that I can use for milling PCBs of various size. 2 sets of those, and then just a couple of flat milling bit and another bit. What else have we got here? We've got this emergency stop button. I probably was tempted to print my own, but this was pretty low cost. I think it was only a couple of dollars to buy this, so this looks pretty nice. I don't know how I'm going to mount it, but the controller itself has the ability to have an emergency stop signal. So I'm thinking of using the signal and not controlling or shutting down the power. I'm not sure if that's the wise thing to do or not. But as I'm probably going to have a laser or a motor which is powered independently of the controller, I didn't want to have 2 buttons. So what my idea is that if I can stop the controller, it will also therefore stop the motors. So it's not a fully safe solution, but it's better than not having an emergency stop button at all, I guess. So I also got these larger T-slot nuts for the base. I can't even think of the good word for the base. See, this is the problem when you live in Japan and you never speak English. You forget all your words. And I also have got some typical sort of T-slot or for those extrusions so that I can mount things on the side of the CNC. And these micro switches here, which I'm planning to use for the end stops, because there's no end stop actually installed on that very low cost CNC, but you can buy these and put them on after. So what do you need an end stop for? Well, currently as it stands, if you try to go too far off the edge, it will just keep trying to go and hammer away at those 4 little stepper motors. So it can't be good for either the controller or the stepper motors to have it grinding away on the accents. So it sounds like adding end stops is a good idea. And as a part of that, the controller has these specialized, I can't remember the model number, these specialized connectors And so I bought these. All these things only just cost a couple of dollars each for a bag of this stuff. So AliExpress again. Thank you, AliExpress. AliExpress is getting a little bit quicker lately, and they're doing a few things to make deliveries a lot easier. So better experience with AliExpress. Although giving lots of money to China does give me pause. Let's hope they get themselves together and stop trying to take over the world. So yeah, here we go. Now these are, I think this was cost me around about $1.50, and I got the short leads because I'm a bit of a cheapo. Apparently if you get a longer lead, it costs like twice as much, which is silly because this gauge of cable is garbage anyway. So anyway, there you go. End stop T-nuts cable connector. And now for the big things, I got a new, look at that thing. What is this? Awesome. I got a new Z-axis, because the Z-axis, that plastic Z-axis, it doesn't look that sturdy. So I really wanted to get a better Z-axis, something that will be a bit more sturdy. And as this doesn't have the ability to mount onto that X-axis rail, I have to get another bag of stuff. So X-axis rail. So these are the linear bearings, or I'm not sure what you want to call them, and they're going to go on the back here. And this is for the lead screw, and there you go. Nothing special, right? So this, you know, when we're talking about, well, what's expensive? $150 for that CNC, pretty cheap. This little baby, along with, it also includes the mount, which is nice, and it will also mount the laser. See the square edges here. This thing here alone costs like $60 US, I think, and these bearings and stuff cost like $20. So this alone is an $80 upgrade to a $150 CNC. So it's yeah, it's not that great. And this laser as well is around about $100. So you know, you have about $180 worth of upgrades just with the laser and this Z-axis upgrade for a $150 CNC. So yeah, you can think about that however you want to think about it, but yeah, it's a bit painful. But it is what it is. This looks very, very nice. And the reason I purchased this is not just because it's a little bit weak, but because I intend to upgrade the motor quite a lot. I intend to make my own motor, and this is a bit of a connection to what you've seen me playing with the motors on the mini lathe and the motor controls and things like that. So my idea is that I'm going to, instead of doing the mini lathe motor controller or ESC, what I'm going to do is I'm going to do a ESC for the CNC and put a brushless motor on this with my own controller, and hopefully I'm going to use the CNC to also cut out and make my PCBs for that ESC. So obviously the idea is to get a very solid and powerful CNC as a result of this, but it's also a stepping stone to upgrading the ESC on my mini lathe as well. So anyway, let's stop talking about it. What I'm going to do is I'm going to chuck all these parts onto that CNC. I don't think there's a real lot of sense in me doing a time lapse or whatever. You seeing me put all the, I mean, whatever. Right? It seems like nobody has much interest in that. What I will do is I will show you what I've done, and I'll show you how I put everything on there, just so you have an idea in case you want to do any of that yourself. And we'll probably do a couple of test cuts with that. It is now still, I don't have the new motor because it hasn't arrived, and because I haven't built the ESC for it, obviously, etc., etc. So for now, I'm just going to be using that little motor that came with it, which is fine, and probably do some tests with the laser as well. So I think it's going to work fine enough at first, and probably be good enough to cut a couple of PCBs and whatever with that little motor. So in any case, let me bring you back once I've got it all done, and I'll see you then. So let me just bring you back for a second here. This is the original stepper motor that comes on the CNC, and this is the new one that I purchased. It looks like the connectors are the same, so I can just reuse those cables as is, but the shaft is a bit longer, which is probably a bit problematic. You'll also see this is a bit bigger
and so this is the more powerful motor, obviously. So the net result is that that shaft means that the coupler is going to stick out a bit further, which in turn means that this rod is going to stick out. Now I've seen some of them have a knob on here, and it's probably somewhat because of this difference in the length, but in any case it's not a negative if this lead screw sticks out a little bit. I'll probably put a little knob on the front here or machine something up in the future, but for now it will just stick out. So another quick tip here, as I was putting this together, I noticed that if you look at the original one here, you'll see there's spaces here, and that keeps this coupler from being too far down, and it means that you get the maximum range here, right? These plastic spaces are not so great, but anyway, that's what it is. So I obviously could reuse these spaces to get something similar on here, but we also have the compounded issue that the shaft is actually longer. So that means with that longer shaft, because of the stronger motor, we really need to have quite a lot of standoff so that the coupler, and the coupler is a little bit different, but we want the coupler to finish probably around about there, right? Something like that anyway. So yeah, well, the first problem is I don't want to use plastic spaces because this is an all metal configuration, and the second issue is that the spacer needs to be longer because the shaft is longer. So what I thankfully had on hand was some old PCB mounts, hexagonal type spacers that have the thread already built into it. The thread was a little bit too long, so I've added one little nut here, but that's good because that actually gives me a little bit more height. So hopefully with that in place, the coupler will not be sticking out much at all, and that means we'll get the maximum travel out of this lead screw here. So let me get that on there and we'll take a quick look. So I got that coupler on there and this mount, and it looks pretty good, right? The spacing looks good, and if you look at the distance here sticking out, it's just the right amount. It's a little bit dark in there to fit in there, so you pretty much get all of the full degree of travel. However, after putting it in, I found that the lead screw is actually too short. Can you believe that? What are they doing? It's just insane. So after figuring out a good spacer for this, it's all been a bit of a waste of time. Well, I finally got it in there. It was a bit of a pain. You can see that the extent, so this much of the travel is lost due to the coupler. So if the lead screw was a little bit longer, then the original arrangement I had would have given the full stroke. There's nothing much I can do about that. Thankfully I had a couple of other different of those old PCB spacers kicking around, metal ones, which is nice and solid, and I didn't have a screw that was long enough, so I took the screw off here, off the original one. Obviously I didn't reuse the plastic spacers, but I think it's okay. It's got a more powerful motor, so should be all good. Alright, get on to the next bit. God, look at this mess. It's getting there. It's taking a bit of time. Good news is that the postman arrived, and I got a whole bunch of these collets. The 11 collets, all different sizes, up to, what do we got? 8mm. So that's quite good. I also got this 20mm flat cut router bit as well, which will be useful for leveling off the waste board. Alright, so I finally got it mostly back together, and that gold Z-axis looks pretty, doesn't it? And it goes nicely with this gold 40-watt laser. Now there are a few little failures which I've sort of faced as far as my ordering and checking. You know, it always happens. You always order something, you get something wrong. And I understood that this was a 52mm hole, and for some reason I understood that this was a 52mm round motor as well. I thought it was a standard, but obviously nothing's all that standard with this stuff. So you can see the laser fits in here quite nicely, so that's a success. Obviously this fits well with this laser, but in fact this is actually a lot smaller. I think this is about 46mm or something like that. So this is actually 52mm. So when I build my own motor arrangement, it's not going to be a problem, but right now this motor doesn't fit in here, so I need to figure out a way to solve that problem. God, look at those screws getting there in trouble. But you know, one of the good sides is that the laser does fit. So, and the laser wouldn't have fit in here. So you know, you sort of solved one problem and created another. But that's okay. And an issue which I already knew is that the way that the bearings are located, it actually reduces your total work height here a little bit as well. It's a well-known problem and can be solved by lifting the whole Z-axis brackets up a little bit, but that also adds to rigidity issues. Now the whole thing seems pretty rigid, but there is a little bit of flex, and the flex is probably coming from these linear bearing rods, which are at 10 millimeters. It's not that bad. This is again a known problem, and a known solution is to change this to 12 millimeter rods and change these bearings out to 12 millimeter bearings, which is not probably a big difficult thing to do, but it's just something I didn't want to invest in right now. So I think the idea is I'll give it a go, and if it's problematic, I guess I'll swap them out too. And the final thing I have to do is add these limiter switches. So that's 2 limiter switches for each axis, so a total of 6 limiter switches. And what I did here is I already added a little grub screw on the side here, and thankfully, because this new Z-axis has these slots in it, I can come up with a little plate to mount these switches. So they just overhang, and they'll be triggered by this. And again, I'll do something for the other axis, something similar as well. So I think what I want to do though is cut those little mounting plates for these switches out of acrylic or something like that, and I think I'm going to try and use this, but obviously the big issue is that I can't use my motor right now, so always something, right? Anyway, I'll solve that problem. Well, something I just noticed as well is that it looks like these linear rods in the old one as well are a lot smaller than the new one, if I'm not right. It looks like maybe 8 millimeters against 10 millimeters here in the Z-axis, so that's a big bonus. And obviously the travel is increased a lot more, so that's going to allow you to use, well, probably longer bits. It's not going to increase your work height, but the longer bits is going to make it a bit easier to be able to select and use things you want to use. And one more final issue which I just forgot to talk about as well is that the positioning of the on the y-axis is such that this z-axis mount means that the center or the cutting point only ends up here. So I'm going to have to shift the whole x-axis rig back a little bit, and there's some degree of adjustment here. I can go back a little bit, but I'm not sure if I'm going to get the full length, the full y-axis length. I might get it. We'll see how it goes. But anyway, I have to shift that back. I think that's not a big issue. So here's a quick look at how I'm mounting the end point switches, these micro switches here. I've just 3D printed these little pieces here, and they slot straight into the standard rail here, like that, and they can be moved around to adjust the position. So in fact, up here is where it'll go, and like this can slide and adjust it, and I've got these little posts on every one of those surfaces, and the micro switch will screw down there, and I'll just use the normal fixture mechanisms here to lock the screw in place. Anyway, I'll show you it when I'm done, but the point is that 3D printing is great. I love it. So after a day and a half of designing and 3D printing, I finally come up with a few bits and pieces, and I haven't actually done the wiring yet, but I'll do that next. So let's look at the big pieces first. Obviously here we have this box for the emergency stop button, and that works pretty good. And I've left it open at the bottom here so I can access the cables, but it's screwed on to the top and bottom rails here, and it's not going anywhere, and that's quite a nice little addition. And as we saw earlier, the threaded rod was sticking out because the lengths of the shaft of the stepper motors is longer, and so I've added these nice little knobs that allows me to adjust the position. I've had one there, and obviously one on the front here as well, which is nice. And I'm just stopping that, I'm just fixing that in place with a single grub screw down in there. It's a pretty tight friction fit in any case, so, but the grub screw just keeps it in place. So we have these switch mounts here, these end stop switch mounts, and they're keyed in place with that single screw, so they're not going to go anywhere. The basic design idea is pretty much the same for all of them. There's another one over here, obviously. And then, let's spin this around here. You can see, there we go. I've also added it to the Z-axis here as well. I had used countersink screws here, otherwise it would actually minimize or reduce the amount of travel I would get, so, but not a big deal. And I've also offset the switches so that they're out far enough so they clear the edge here. So this is really the only place where I had to actually modify the standard hardware, and all I've done is added this grab screw here. So I've drilled and tapped a hole and added this grub screw as a post to trigger these end switches. Pretty straightforward stuff. But otherwise I've been able to pretty much just use the standard rail systems and screws. I haven't opened any holes or done anything tricky, and I was really aiming to do that. See if I can swing over here without destroying it. You can see I've also added a post here on the bottom plate, and I have two more end switch mounts here and here, and again they're keyed into place, a single bolt, and keyed into place so they don't spin around. So that's worked pretty good. So let me get that back over. So I think it looks pretty good. Oh, and obviously the other thing I forgot was the motor spacer, which I've added here. And this is not ultimately the motor I think I'll be using, but in any case for testing I want to be able to use it, so I've added the motor spacer there. So as I said earlier, I'll have to do the wiring next. I'm going to do that all off camera. It's an extremely boring and tedious process that nobody wants to watch. Oh, there's another post here in case I didn't point it out earlier that I've added for the end stop switches. But looking good so far. Pretty happy with how it's all working out. So as I said before, I'm not going to show you a detailed video on how I wired this all. I mean, there's a lot of videos on the on YouTube that you can see about these specific CNC routers, so I feel like I'd be just treading over old ground. In any case, I'll give you a bit of an overview of what I've actually done. You can see here where I've cabled to the end switch here, and heat shrinking, etc. And then I've ran the wire inside the slot here. You can see I've got a cover on that. Now the cover I did actually end up 3D printing these. This is the profile, so you can sort of see that's the inside, and that's the profile. It's just a little something T-piece that can actually fill in these slots. See, just like that. It's actually quite good. Now they sell these types of covers on AliExpress or other sites, and I actually just, for some reason or not, decided not to order it. So instead of waiting a month for it to arrive, I decided just to print it myself. This is just printed in TPU, nice and flexible, and I think it looks pretty good actually. I'm pretty happy with the result. And you can see the other micro switch here and the cover, and then I'm just running the cable out there. So I haven't finished all of the wiring yet, but I finished installing all of the cables and terminating them, which really took quite a long time, took a good part of a day, nearly all of a day. And even though I said I wasn't going to do any more 3D printing, or that I'd finished 3D printing, I ended up printing quite a lot of extra parts. For example, here you can see I've created this mount for tying the cables to. It's got little slots in it that I can use cable ties on. And then all of the cables here are terminated like this, a big mess of cables. So how to deal with that is a bit of a problem. And what else did I print? I also printed these little holders here. You can see here is a pipe, and it's just inserts in here and can rotate. So I'll have two of these holders which will hold the cable, and I'll just use this spiral wrap here to hold the cable. Now this is actually just a piece of antenna pipe from a radio control car. I have a couple of those, and I'm using this like insert. You can see the design here. It has a hole in the top and bottom, and then I'm just using these little friction fit round things that go in there and then slot in, and then that's never coming out. It doesn't matter how much you pull on that. So it's very, very easy to install and gives that pivot. Now why do I pivot? Well, these pipes are really quite hard, so if I just hard fix these two
the frame end here will actually put quite a lot of tension on the head here. So having this to be able to pivot is probably a good idea, I think. And the cables will naturally flex inside the spiral wrap, so I think that's going to work well. So the big question is, what do I do with all these cables? Here you can just see, just getting off topic, where I've terminated those little leads here. And I've connected the ground shield as well, so that it's onto the negative pin for all these, because I found out that the ground pin, or one of the pins is actually the ground. And I read or saw some video saying that some noise issues, picking up noise and affecting the microcontrollers, are a problem with this endpoint cabling. So I think the shielding is quite good idea, maybe. And while we're looking at the last cable that I made also this probe cable here, which is another similar cable with a couple of alligator clips on the end here. So back to the topic of what do I do with all these cables. Well, a younger and less wise version of me would just chop all these off and connect them directly to the shortest possible path. But as you can see here, I've left quite a long loom, and so obviously I've done that because I know that, you know, the wiser and older version of me knows that things change, and if you want to move something a little bit and you don't have any ability to have a bit of extra cable, then you're pretty much, you know, struggling all of the time. So advice to you young'uns, leave your cables long and then tie it off somewhere and feed it back to your connection. But obviously this is going to look ugly on a big bunch here, so what I've done is I've made this little box here, and it's the same sort of design idea as this one here. We'll go there, and this box serves a dual function. One is it provides a place to sort of hide all the cables. I can just stick all of the overrun bits in here, but also gives me a path to route the cables back through to the top connectors, and it also brings a path for the cables to come from these cable holders back to here. And you can see here I've actually got exactly the same type of termination point, so I can actually bring these pipes coming from, say for example here, I'm not putting the little pipe in because they're quite difficult to put in, and then going here, and then as the head moves that will rotate around. So I've got two. The reason I've got two of those is because I'm going to have one dedicated for the motor head, so motor or vacuum or air assist. You know, as the motor head changes to different types of items, I'll be swapping out the cables quite often. So this other one here will be for the servo and the endpoints. So I have two basically. And it also reduces the overall stress on each of them. I think it'll look pretty cool like that as well. So unfortunately I didn't have two black ones, so I've got this green one which looks a bit pants to say the least. And just one point on this is that, you know, anyone who's watching this channel know that I hate supports and I never use supports. So this is actually printed like this, just like this was also printed like this. And you'll see that I actually am using a support for once. I'm actually using a support to support this overhang here. And it's, well, as much as I hate supports, I must admit this is quite useful in this situation. So I'd say I hate supports, I don't use them, but I will use them, and I use them sparingly. So anyway, let me see if I can tidy this final bit of stuff up, and I'll get you back so you can have a look at what that looks like. So there we have it. Finally finished this thing. Looks pretty good. You can see where the main cable loom comes in, and then at one time I push it into the box, and then either going up or at the bottom, and then back out, and connecting all of these end stop connectors here. And I've just put a bit of spiral wrap on there to hold that all together. So all the different, obviously these cables coming in are all different lengths, but I just shove, you can't really see it, shove everything up in the box there and just sort of sits in there by itself, so it works pretty good. And out of the top here we have the exit hole going to the motor controls, and you can see that these work pretty good. So this one has the end stop and the stepper motor control, and this one here has the motor control. And I haven't run this inside the box or anything like that, I've just connected it here because obviously this, what's in the content of this line here changes. And you can see the little pivot points here and here and here and here.
And just for thoroughness, I'll show you where I've run these Z-axis end stop cables. So this cable runs down in, sneaks in behind, and I've actually run it inside this V-slot here. This is actually a V-slot. These are not V-slot, by the way. So this runs up here and then sneaks out the side here, and then everything sort of bundles up there. Now the V-slot shape is a little bit different, so this is here. I'm just putting this here because I had some left over. So this filler strip that I made, that I printed, is a little bit loose on the V-slot style, so I actually put a bit of double-sided tape on there first just to make sure it doesn't fall out. So I think it worked out pretty good. And here's the probe cable here, which I'll just plug in the back there. So I need to get it plugged in and tested. Make sure I've got these switches connected to the right location. But if it's wrong, I'll just swap them around a bit, but should be okay. So what do you think, folks? It's a pass. I think it looks pretty good. Pretty happy with that. And the styling's pretty good because I've used all of this burgundy coloured PLA plus, which sort of matches everywhere, even in the button here. So yeah, looks pretty good. Happy with that.
Well, that's been a bit of a slog, so that's about it for this episode. Apologies for not actually showing the CNC operating within the videos that I've shown. It's sort of been just a slog to get it together. But don't worry, there's going to be plenty of action and plenty of shots of the CNC in use in the future episodes, so you'll just have to be looking out for that. So in the next episode, it's still going to be a little bit of a preparatory episode. I'm going to be looking at how to set up the working surfaces, the working mounting methods, and the probing methods for the CNC, and really taking the next step just before we actually start doing some serious machining of PCBs. So hang around for that. I hope to see you then. And if you haven't already, don't forget to subscribe, like, comment, or do whatever the hell you like. It's fine by me. Anyway, I'll catch you in the next episode, so I'll see you then.